Hey, good morning. Today we're going to continue working on arithmetic sequence, and now we're doing the Savvas lesson here. And so on the arithmetic sequence here, we're going to have a new word today. It's called a recursive formula. But let's start back with what we've been working on. We've been working on this one called the explicit formula. So on your notes I would write this because we should know this one by now. This one's called a sub n, the number I want, equals a sub 1, the first number in the sequence, plus, very important, there's a plus sign there, number I want minus 1 times my d. Okay, we should know this one by heart now. Now the recursive one is our new one today, and it looks like this. It says a sub n equals a, now sub n minus 1. Excuse me. N minus 1 is our sub here. So it was in parentheses up here in the explicit formula, and now it's a sub number down here. And then we're going to say plus our d, whatever our difference is. And so a lot of times on this recursive formula here, you need to know the previous number. That's what this means. What is the previous number? And then we're going to add the same difference each time. But on this formula, you have to know this guy. Okay? So this guy is kind of good for like if you're writing a formula in a spreadsheet, and it's going to be the same process over and over. You're adding or subtracting some number to the previous cell. And so this one's good in computer programming or writing a spreadsheet. And a lot of times you do this as an adult. You have a spreadsheet in Excel, and you want the next number to be, a certain amount above or below whatever the previous cell was. This guy here looks something like this, but you have to know this, a sub 1. They have to tell you what the first number is, and so that's going to happen today a lot. On your homework, it's like we got to figure out what the first number is. And so let's just start with a simple one. If I say my first number is 12, so that's my first number, and my d, let's just make one up, my difference is I'm going up by 3's, well then I know my second number is going to be 12 plus 3 is 15. Okay? So now if I want the third number, I got to know this guy, 15, and so then plus 3 is going to be 18. So you have to know on a recursive formula two things, what the first number is in the sequence, and then the difference that you're going up. Now this formula would be terrible if I said, well, what's the 44th number? I wouldn't use this formula because I don't know what the 43rd number is, and so I'd have to do this plus 3, 43 times, so I know what this number is, so that I could find the 44th number. I need to know the 43rd number. So in that case, I would use this formula. Okay, so you got it today. Part of the problems on the Savvas lesson is, well, when would you use these formulas? Which one? So if I know the 43rd number, well then I want to use the recursive formula. I'm not going to do all this work. I mean, you'd still get the same answer. I just take whatever the 43rd is and add my difference to it. Okay, and so that's kind of what we're going to watch for today as we're going through this lesson. All right, all these other terms you probably know. Common difference, that's my d, or what are we going up or down by. In arithmetic sequence, we have to have the same number happen 3 times from one number to the next, where you're adding or subtracting something to get the next term. Alright, terms, we already know this one. First term, second term, third term, so forth. Okay, so all these words here kind of we should be familiar with. Alright, so here's your warm-up for today. It should go pretty quick. They're saying looking at the number of rows, and we want the total number of people down here. So in row 1, they're starting down here. Row 1, there's only one person, and the total number of people in the group would be 1. But if I added another row, now I have 3 people in that row, and total now I have a total of 4 people. And then if I go to the next row, third row, 1, 2, 3, 1, 2, 3, 4, 5 people are in that row. And now total I have 9. So fill in these other 4 here real quick, and I know it's tiny on your paper, but then start looking for a pattern here. Okay, alright, pause your video, come back when you got them filled in and an answer down here for B. Alright, this one's got a kind of a unique pattern that as I looked at this, I looked at 7 people were in this row, and then I start to see this pattern. If you do it enough times, you say, hey, you know what? However many people are added, I just added to the previous number. So there was 3 people in the next row, and prior to that there was 1 person total. So now I have 4 people. The next row had 5 people in it, so I had 4 to begin with, and I added 5 more to it. Boom. Now I have 9 total. So this is what we start to call the recursive formula. Hey, take the previous number, and then how many did you go up? You went up by 7. So 9 plus 7 is the next number, 16. Okay? So it's the next number is the one before plus the number of people that are in that row. So the one before plus the number of people that are in that row. So they're kind of leading us towards, we need to know 2 things here. What's the next row, and then what was the previous row? Okay? Alright, so this guy here we should go pretty quick because we've done this before. A sequence is an ordered list of numbers. Arithmetic sequence, we still keep going up by the same amount every time. So all of these words kind of, we've already talked about a lot. So this part of the lesson will go pretty fast today. If I went from 26 to 39, now it's a little bit bigger spread today. So what we want to do is, if we want to find it out quickly, we're going to take 39 and subtract the number in front of it, minus 26. So if I do 39 take away 26, I get 13. If I took 52 and subtract the number in front of it, so do that on your calculator right now real quick, because these are a little bit further apart, so it's not as clear what the difference is. Yeah, you get 13 again. So again, take that number, subtract the 1 in front of it, I get 13. And this method of finding the difference, of take the number and subtract the 1 in front of it, really works well when we have some weird decimals, okay? So that's a good thing to know, is take the number and subtract the number in front of it. Okay, and we get 13 all the way, and so there is a common difference that we're going up by 13s every time. So you see in the arithmetic sequence on the explicit formula, we needed to know the D and the first term. Now, here's something they talked about, and I want to highlight this. You can put a box around it. You can think of a sequence as a function where the domain is restricted. We talked about restricted before. What's the rules? And for restricted on number sequences, they have to be natural numbers. Okay, you cannot have a decimal of a term. And so natural numbers were those kindergarten numbers, 1, 2, 3, 4, etc. Okay, so you can't have a decimal of a term. That's one of your questions today that they're going to ask you about. And we talked about that a little bit just yesterday. Okay, so the first term and second term, you can't have a 1.5 term. And so as we look at this guy here, we're going from 39 to 26, and I didn't do this, let's just make sure. 39 to 26, so if I did 39 take away 26, I'm going up by 13s every time. And so 26 plus 13, I'm back to 39 again. So it looks like we're going up by 13s every time here, okay? So if I have the first term is 26 and the second term is 39 and I add 13, and so I can keep going this way, okay? They're just trying to teach you a little bit about how to read this stuff. Like, this will be our first day, and remember this back from junior high days. A sub 2 means the second term is 39. So it's just basically pointing out how do you read subscript here and subscript notation to refresh your memory. We've been working on it for a couple days now, so we're pretty good at that. Okay, is the domain of function in part B of example 1 continuous or discrete? Very important. Are we going to have a continuous graph or a discrete graph? Well, think about what we just said up here. Boom, boom. You cannot have decimals. Okay? So, write your answer there. Whether it should be discrete or continuous. I just gave you a big clue. Alright. Welcome back. It's got to be discrete. It says in problem, only natural numbers. And natural numbers are those counting numbers of 1, 2, 3, 4. and we need to say it's restricted to just natural numbers, okay? So restriction means what rules apply to this math problem, okay? Let's just leave it at that for right now. Restricted is basically a rule. Can't think of an example on the top of my head here. All right, the recursive rule. Now this is the new one. This is biggie. So this is where we're starting. Recursive rule in mathematics means repeat the process over and over again using the output of the step. Each step has the next input. The recursive formula relates to each term of a sequence to previous terms. So this is the biggest. I need to know the previous term. It is composed of an initial value and a rule generating the sequence. So the first term, we know that. A sub 1 means the first term. So when we write the rule, we're going to say a sub n, whatever term we want. And now this a n sub n minus 1 means what's the previous term. So we have to know this guy in order to use this formula. Okay, and then we're going to just add it or subtract whatever the difference is. Okay, so again, it's good for like writing computer programs. For example, this step that's going up says, what's the recursive rule for the height above the ground for our nth step of this pyramid shown? So they're saying now we have to write the recursive rule. So that's that sub number here, n minus 1 under the sub here, okay? Now as I look at the step, each step is 26, so 26 centimeters plus 26 plus 26 plus 26, it's a repeating pattern going up here. I have to say what the a sub 1 is to get this going here. Okay, so usually you do two things when you write a recursive formula. You say what a sub 1 is, where did we start, and then how much are we going up every time. Okay, so if I wanted to know what the second step was, I know my first step is 26 here, so I'm going to take 26 plus 26. Okay, and I get what, 52 I believe would be the second step, and so forth. Every time I'm just going to add 26 to the previous number. Again, here they are kind of breaking it down. Same thing. My first step is 26, so that 26 needs to go here. My D is a 26, so I'm going to put that here. D is 26. Every time I'm going up 26 centimeters. So my next one's going to be 52. If I want a sub 3, then I want to take the 52 and add 26 to it. If I want a sub 4, I want to take the 78 and add 26 to it. So again, this formula, in the past I kind of said, well, what's the whole point of this using this formula? If you have to know this one, just take that number and add whatever your difference is. Okay? So, it's pushing our brain a little bit here today. We need to push our brain. So now, I want to do this one with you. It says, write the recursive formula to represent the total height of the nth stair above the ground if the height of each stair is 18 centimeters. Okay, so I already know on step 1 my differences. We're going to keep going up by 18. I also know my a sub 1 is 18. On the first step, I'm 18 centimeters, so a lot of times these are kind of put in there. Now let's write a sub n equals a n minus 1. You're going to get really good at writing this on the formula, on your homework today. And I'm going up by 18 every time. So, it looks weird, it looks hard, but you just need to know that I'm adding 18 to whatever the previous number was. If I wanted a sub 2, I'm going to put an 18 here, because that was my a1. The previous number was 18, so 18 plus 18 is 36. Now again, I can't do this. I can't say, okay, what's the 33rd number? Because I would have to know what the 32nd number is in order to use this formula, and then I just add 18 to it. So this formula is not good if I don't know what the previous number is. I'm going to use the explicit formula. Okay? Alright, you can kind of see why, Fisher would say, hey, you know what, we're short on time, let's just skip that part of the lesson. Alright, now the explicit formula, this should go pretty fast because we've been working on this one for a couple days. This one's a big one for me. We already know all this. A sub n equals a sub 1 plus the number I want minus 1 times my d. A lot of times kids forget there's a plus sign here. I'm not sure why. They just put this number and touch in the parentheses, and then they multiply all these guys together. Arithmetic sequence has to have that plus sign in there. Okay? Alright, so if we're looking at this guy, looks like it's a sequence. I'm going up by 1s here, and here I'm going up by 12. So they helped us out here. Now I'm going to show you a little bit something that's going to be a little bit different here today. Okay? So hang in there with me. So just use the explicit formula. A sub n equals a sub 1, number I want minus 1. I just want to make sure that I'm in the right place on my notes here. Oh yeah, a sub 1 plus the number I want minus 1 times my d, which is a 12 in this case. Okay, I guess we can go back here and replace this a sub 1 because we already know what the a sub 1 is, so let's do that. A sub 1 was 26. Okay, now here's, normally we would just kind of say, okay, let's find a number, but what we're going to do is we're going to condense this a little bit. We're going to make this formula look a little bit different, because this happens sometimes. If we're going to use the same formula over and over and over and over again, I don't want to have to do this whole thing here. So here's what we're going to do is we're going to make this a little bit more condensed. We're going to take this 12 times everything inside the parenthesis. And I still got this 26 here. Okay. Now I have, just like we were practicing yesterday, I have like terms. 26 take away 12 is 14. So now I got 12n plus 14. So now this is looking like y-intercept form here, or slope-intercept form. There's my, what I'm going up by. I'm going up by 12s every time. There it is. And if I was at 0, it's going to be at 14. Now if I took 14 plus 12, I'm back to my first number here. So if I was looking at this on a graph paper, I have 0 here, and then I have 1, 2, 3. I already know 1 is 26, so that's up here somewhere. And then if I added 12, that's going to be 38. That's going to be up here somewhere. And so if I'm looking at a linear line, even if it's discrete, I know that that's going to go across the y-intercept at 14. So what we're doing is we're taking this and we're condensing it. Okay, so I'm going to say a sub n equals 12n plus 14. Now for some reason on your homework today they have it written like this a whole lot of times. They have the 14 first plus your 12n's. So it doesn't matter because they're both on the same side. If I was going for slope-intercept form, I'd be writing it this way, because there's my y-intercept, there's my difference. Go up 12 over 1, up 12 over 1, and make your dot. Go up 12 over 1, boom, there's my next number, up 12 over 1. Again, you would know that this is a discrete graph, that you would not connect these dots. So sometimes if we're going to keep doing the same thing over and over again, we're going to condense this. Okay, so look for that today. And there it is. There they are too. They're writing the 14 first, which I'm not sure why they're doing that. So now watch. We want to find the 10th term, and here is our graph over here, by the way. So they started making these dots, even though, you know, it's a discrete graph. They just used the up 12 over 1 to get the next number. They said let's find the 10th number. So we're going to write a sub 10 equals 14 plus 12 times 10. Well, I know 12 times 10 is 120 plus 14, so my a sub n equals what, 134. Okay, so we can, whoops, I forgot to say a sub 10 because I told them what number to get here, sorry. A sub 10 equals 134. So let's just, you can just watch for this. Let's do a sub 10 equals now my first number in the sequence. Now this is important. I want to put a little 1 here because I want to know what the first number in the sequence is. So 12 times 1 is 12, so 14 plus 12 is 26. So that's how you find the first term, is you put the n sub 1 here. 26. So now I can rewrite the explicit rule. My first number is a 26. Now it's very important how I got that 26. I want to go over that again. I want to put a 1. If they give me the formula like this and they said, okay, I want you to write the explicit formula, I want to put a 1 in. 12 times 1 is 12 plus 14. That's my first number. Is going to be a 26 in the sequence, and there it is. First term is 26. Now I'm going to continue on here, plus the number I want, minus 1, which would be a 9. And I'm going up by, here's my difference, I'm going up by 12s, okay? So now I got 12 times 9 is 108 plus 26. And I still get 134. Now I'm going to just kind of pause here because that was a whole lot. A sub 10 equals 134 as well. So if they tell me take this number here, and they will today, they said, hey, you know what, here's a formula. Write me the explicit formula. And so you might put a note by this. This is my slope. I'm going up by 12, so that my D, I want to put that over here. My D is a 12. But now to find the first number in the sequence, I got to put a 1 in here, and 1 times 12 is 12 plus 14. I'm going to say my A sub 1 equals 26. Then I can write this formula correctly. Okay? So, a lot's happening here. Manipulating formulas around to what's going to be most helpful. If I'm going to be graphing this guy, I want to take this explicit formula that's right here, and I'm going to condense it down. Okay? Alright. We can use it both ways. Apply the explicit formula. And they said the cost to rent the bike is $28 for the first hour plus $12 each hour after additional hour. Write an explicit formula to rent the cost of n hours. What's the cost of riding the bike for 6 hours? So that was a whole lot up there. We should probably do this one together here. Okay, so now to rent the bike for is $28. So that means they might have had some kind of a flat fee here, because I see it's $12 every time. And so what I need to do is kind of think about that for a little bit. If we were to write the explicit formula, we could just do it this way. A sub 1 equals 28. That's my first number in the sequence, plus the number I want minus 1. And I know we're going up by 12 every time. Okay? So, write an explicit formula to rent the cost for n hours. So, they said, now I want you to do an explicit formula for n hours, so we have to condense this guy. So that would be 12n minus 12, and I got 28 plus. I got like terms here, so a sub n, that should be an n up there. 28 take away 12 is 16. So I got 16 plus 12 n's. So now, I like to write it this way, 12n plus 16, because then it's in slope-intercept form. I can determine several things about this guy. At 0 time, so if I was looking at this, a flat fee, that's my flat fee. This guy's got, you walk in the door, you're going to pay $16. So that's a really helpful formula when you take this formula and condense it down. $16, and then he's going to charge $12 every hour. So let's go up here and use this formula, and then we'll use this one. You'll see we'll get the same thing. They want to know for 6 hours, so let's use the one that you've been using. A sub 6 equals 28 plus the number I want minus 1, which is a 5, times my D is just 12. So let's do this. 5 times 12 is 60, and I got 28 plus 60, and that would be 88, 60, 70, 88. So my sixth number is 88. So it's going to cost $88 to rent the bike for 6 hours. Now, again, you might just sit back and watch for this one. I want to use my condensed formula here. I'm going to say a sub 6, because I want to know the 6th hour, equals 12 times 6 plus 16. Well, 12 times 6 is 72, and 72 plus 16 is 88. And I got the same answer. Okay, so if I was going to keep doing over and over again to find these numbers, I'm going to condense this thing and I'm going to put it in n hours here. I'm going to condense it like this. Okay, so watch for that today. They'll talk about, hey, you know what, put it in explicit form, and then they'll say, hey, you know what, put it into cost for n hours here. Okay, so most of the time they want it written like this, but every once in a while you might see it written like this, especially if you're going to do the same steps over and over and over again. Okay? Alright, that's what all that notes there would say, but we did that one together. Okay? Again, it's just taking math and manipulating things around a little bit. Now we're back to that recursive rule. And this is that, got to know the number before, when I see that my difference is a plus 4. So understanding things like this is super important. I'm reading the formula. So a sub 1 means I want to have a 7 here. They told me that, and I'm just going to keep adding 4 to get the next term. So 7 plus 4, let's see, what are they doing? Oh, I see, they gave us a recursive rule. They told us the first number, and they told us the common difference is 4, and now they want you to write it as an explicit rule. So this goes pretty easy because they got to give you this. So there it is, 7, and I know my D is a 4 here. So now I have just made that into an explicit rule from a recursive rule. But again, you have to know what to find the numbers. Well, that's my difference right there. Okay, so now we can use this to find any step above the height here. We're adding 4 inches every time. And then they're starting off, which is kind of weird. The first step is 7 inches, and then from there we're going up 4 inches every time. Okay? Alright, so that's how you take it from one to the other one. So you see how they're telling us you got to say what the a sub 1 rule is? Alright, so you give it a shot. They want it written in explicit form. Okay? And over here we have a decimal. They have to give you the first number. To -1 and 10. All right, give this a shot because that's pretty easy. So pause your video and then let's just see what you did. Okay, let's see what you did or what I did here. All right, so look in here. I can see that my D is a -3. It's right there. My 10 is my a sub 1, so the 10 goes there and the -3 goes there. Okay, now if I wanted to, I could put this now into slope-intercept form by just multiplying this -3 times everything, collecting my like terms. So sometimes you'll see it. Sometimes they'll just say leave it in an explicit formula, which would be this guy. And so sometimes they'll say put it in the nth term, so that means put it, you know, reduce some things or get some math taken care of, business taken care of. Okay? Over here, my D is a 2.4. I see my a sub 1 is a -1, so there is my explicit formula right there. And again, if I wanted to just kind of condense this thing, take 2.4 times everything inside the parenthesis, put your like terms together, and now it's -3.4 plus 2.4 n's. And so again, I would do this if I want to keep doing the process over and over and over again, that I didn't have to write all this out. Okay, it's a little bit easier to use this formula down here once you condensed it. But if I'm only finding one number, I'll leave it just like this and do my math, okay? Alright, so that's what that's all about. Now, sometimes you have to find the first number. So here's the formula here, but 1 is not the first number in the sequence here, okay? So what we're going to do is we're going to put a 1 in for the n. I want to know what the first term is. And if they're doing here is they're putting a 1 in, because I want to know the first term, a sub 1. So I put a 1 in for the n, and then -1/2 times 1 is -1/2. So that means my first term in this sequence is a half. So might put a star by this one, because if they say, hey, take this recursive formula and write it into explicit, I need two things. I need my first number and I need my D. So now this is how you find it from on here. You put a 1 into this formula because they told you this is a recursive formula. Oh, they said explicit formula for arithmetic sequence is this. Interesting. What's a recursive formula for this sequence? Okay, well I still need these two things, what my a sub 1 is and what my d is on either one. So my first number is a 1/2, a sub 1, and it looks like my d is right there. It's a negative 1/2. So now when I come down here and write this, I need this guy. So here it is, a sub n equals a n minus 1 sub n minus 1 minus a half. Okay, so I need my difference. If I was going to, and they're going to also ask you this, what's your a sub 1? Each time they're going to say, what's your a sub 1? So I guess this is the condensed conversion of the explicit formula like we were doing up above. That's why it looks kind of weird, but we have to be able to recognize it. Okay, so it did start out something like this, a sub n equals a sub 1. Well, let's just put that one in there. Now we know what it is. It's a 1/2 plus the number I want minus 1 times my negative 1/2. Now look, that's what it really started out as, and then they condensed it. They took a negative 1/2, that's minus 1/2 n's. Negative times positive, or negative times negative is a positive, and 1/2, so that's my plus 1/2. And I have a half over here. So what's going on here? 1 times 1/2 is a half. So a half and a half is a 1 minus 1/2. Oh, that is what they had up there. Okay, so this and this are the same thing. This is what it started out with. They condensed it. So we just got to know the forms. So again, this is a condensed form of the explicit formula. We're going to put a 1 in because we need our a sub 1. They're going to keep asking us for that. So we're going to put a 1 in there and do some math to find out this guy. I told you this one's going to hurt your head today. You're going to need your notes today, and especially I think there's 29 math problems today that you practice these things real fast. You're going to get real good at it, okay? So here's, write a recursive formula, and they gave us the explicit, but they give us the condensed form here. So I need two things. I need my a1, and I already know my difference here, and this is why I gave you so many problems. My difference is right here. It's my slope on this guy. So it's a slope of 3. But now we're going to put a 1 in there to find my a1. So an equals 8. 1 times 3 is 3. So a plus 3 is 11. So my first number in the sequence is 11. But now we're going to use these two numbers. We don't even need this number to write the explicit or recursive formula. It's just going to be a sub n equals a n subscript 1, and now plus my 3. Again, this number you need to know the previous number. So if I know the first number is a 3, I'm going to put a 3 here. 3 plus 3 is 6. That's my second number, second term. So now that my second term is that, if I want the third term, I want to put that 6 in here. 6 plus 3 is 9. So that's my third term. I keep going up by 3's. And the next one's going to be 12. So again, this is why I didn't see this one as being very valuable. But on your homework today, they're going to keep asking you, okay, well, based on this formula, what's my a1? You're just going to put a 1 in. Find that number. And then you're going to take that number, since I know my d, and you're going to put it into the recursive formula here. Okay, so we need the a1. I already know my d, so look for this guy. It's right here. We're going down by 5s every time. Okay, so now if I put a 1 in for that, I have 12 minus 5, so my first number is going to be a 7. And now I'm going to write the recursive formula. So it's a sub n equals, this is going to be always here, n minus 1. I want to show you how to put this in on your, because it took me like an hour to figure out, okay, where's this button? I kept putting A and down button. Anyhow, it's a long process to find this guy here. For me, it was anyhow. And I need my difference, which is a minus 5. Okay, so there it is, recursive formula. This is what I'm going to type into my computer. And they're always going to ask you, okay, well, what's the first number in the sequence? Okay? All right, that's how you find it. This is the explicit formula, but it's condensed formula, okay, where they got rid of some things. It looks like I wrote, that's not good. I didn't write it. I wrote the explicit formula here. I'll have to fix that on my notes up here because I didn't read the directions. We want the recursive formula, so the recursive means that minus n. Okay. All right, now this is what I was talking about. One of your math problems, a lot of your math problems will ask you this. They're going to say, okay, well, what's my first number? Well, this is kind of easy, especially on this graph one, but most of the time it's not a graph one. So if I go to my first term, what is my y value? A sub 1 is a 2, so the 2 goes there. Now, they said, okay, well, write me the recursive formula, so you have to figure out what are we going up by from this number to this one. Well, they're counting by 2, so that's 2.5, so that'd be 3. So that's my difference. We're going up by 3 every time, looking at this graph. So there's my plus 3. So now, you got to do this subscript. Now, I looked for this button all over the place. And you see how it's right there right now because I used it so many times that I think it put it up here. It might be on your tomorrow. It might be already here for you. But I had to hit more, and then I had to look at all these different buttons, and I was starting to think it was one of these guys down here. But if you hover over this guy, it'll say subscript. Okay, so you're gonna hit this little guy, and then you're going to put A, and I think then you hit this little guy to put this, and you have to have it in parentheses, n minus 1 in parentheses plus 3. Another thing that came up yesterday when I was doing my homework, it was something like this. It was A sub n equals A sub 1 plus the number I want minus 1. And if this guy was a negative 3, okay, when I put this guy in, if I don't put parentheses around it and I say, okay, well, what was the number? So let's just say this was A sub 1 equals 12. Let's just say this. And they said, write me the explicit formula. So I want to have 12 plus n minus 1 minus 3. If I put that in just like that, it's going to say it's wrong. Well, I got to do the A sub n equals. They're going to say it's wrong. And then I said, well, what's wrong with that? My D is a negative 3. And so then I kept looking and looking, and I kept doing it. And so then it says, okay, well, the right answer is this. And I'm thinking, what? Well, it is 3 times all this thing, and then I want to change the sign because, you know, that's going to be a negative 3, and that's going to end up being a plus 3. And then it's like, wait a minute. I have to put this guy in parentheses. Okay, so anytime you have a negative difference and you're doing the explicit formula, put that guy in negative 3. And then I was getting it right. But they kept showing me this answer when I was getting it wrong. And it's like, what am I doing wrong here? So after I thought about it and studied the problem, and that's what you have to do, why am I getting it wrong? And why would they put a negative sign there and just a 3 right there? Put this guy in parentheses, especially if it's a negative. Okay, I guess Mrs. Tilton's been teaching that all along, is put these guys in parentheses, whatever your difference is when you put it into the formula. So her kids shouldn't have no problem. All right, so you got quite a few problems there to do. Study it, look at the answers when you miss it, and say, okay, well, how did they get that problem, and how did they get that answer from that problem? Okay. All right, it's going to take a little bit of a push. We're going to do it in class tomorrow. We'll give you plenty of time in class to do it tomorrow. So there's no homework tonight. That was a lot for today. And so tomorrow we'll go do the homework. All right, have a good day.